You know, the strangest thing is, Earth looks completely normal until you look at it through the eyes of physics. We've lived on this planet for so long that we've grown familiar with it, to the point that no one even bothers to ask whether normal is really a fair description anymore. But if you and I sit here and we start looking at everything the way a physicist is forced to look, down to the very smallest scale that nature allows, then suddenly Earth becomes something so bizarre that it's hard to believe it even exists the way it does. To see whether Earth is normal or not, we can't start with mountains, oceans, blue sky, or white clouds. No, that's way too big. We have to zoom way down. Smaller still. So small that no human intuition can handle it. The atom. An atom is about n-half meters across. Try to picture this. If an apple were the size of Earth, then an atom inside it would be the size of a small room. And the nucleus inside that atom is smaller still, about 100,000 times smaller. Meaning if the atom were the size of a stadium, the nucleus would be the size of a mosquito hovering in the middle. And the rest, all the space between the nucleus and the electrons, is almost completely empty. Not mostly empty, but 99.9, 9999, 9999, 9999999, 9%, absolutely nothing there. You, the chair you're sitting on, the table in front of you, everything you know, all of it is almost entirely empty space. What creates the feeling of solidity is just the electric charges of electrons and protons repelling each other at exactly the right moment, in exactly the right way, with a precision that's almost uncanny. An electron carries a charge of 602 kT, 1/7 coulomb. A proton has a mass of 67 kT, 1/7 kilogram. Those numbers sound so tiny, they seem meaningless. But if you change them by even 1%, just a tiny fraction, no one on Earth would even feel. Water molecules could no longer form stably. Water would no longer be water. Hydrogen and oxygen wouldn't bond the way we're used to. And the entire chemistry of life on Earth would collapse instantly. No oceans, no clouds, no rain, no cells, no trees, no creatures, no us. Just from a tiny change in the electron's charge, the whole planet would become a dead world. So when someone says Earth is normal, I usually just smile. Normal? Try looking across the Milky Way galaxy, which contains roughly 100 to 400 billion stars, and count how many places have physical constants that combine so perfectly. The real number astronomers have found so far is tiny. So tiny that if you rolled a die with hundreds of millions of faces, you could roll it your whole life and never land on one that matches Earth. And all of this is still just at the atomic level, a level no one can see with the naked eye, yet it controls everything that happens at planetary scale. The interesting part is none of this had to happen the way it did. There is no law of the universe that says the electron must have exactly that charge, or the proton exactly that mass, or that water must form from that particular hydrogen-oxygen mixture. Yet everything lines up precisely as if someone stood behind it and fine-tuned every single detail. Once you start from the atom, you can no longer see Earth as an ordinary planet. You see an absurdly delicate structure where particles smaller than anything you can imagine determine the color of the sky, the existence of rain, the shape of the oceans, and even whether you're sitting here listening to me right now. That's why I'm telling you this right at the atomic level. Earth is not normal at all. It is a beautiful exception of nature, a dice roll with an outcome so improbable, it's hard to believe, and we've only just begun. So you could say trees are made of sunlight, and that wouldn't be wrong at all. And if we go even further back, the CO halve, the tree absorbed, wasn't always in the atmosphere. It came from the Hadean Eon, about 4 billion years ago, when Earth was still molten and continuous volcanic eruptions, released enormous amounts of CO into the primordial atmosphere. That means the carbon in a single log may carry traces of eruptions that happened hundreds of millions of years before life even began. From CO and sunlight, trees built the entire living world. To do that, Earth absorbs roughly 3 pachutenio joules of solar energy every year. A tiny fraction of that energy is used by plants to split carbon from oxygen in CO molecules, a process so energy intensive that if plants didn't do it, no natural phenomenon on Earth could perform it efficiently. But photosynthesis isn't just a clever chemical trick. It's the single greatest turning point in biology, appearing about 3.5 billion years ago. Without photosynthesis, Earth would resemble Venus, choked with CO, baked at 450 degrees Celsius, and completely incapable of supporting complex life. No free oxygen, no animals, no ozone layer to block UV, no blue oceans, no clear sky, no fire, and no us. So when you look at a flame, you're witnessing something extraordinarily special. Photosynthesis stored sunlight in chemical bonds, and fire releases that sunlight back into the universe. Sunlight hits a leaf, gets trapped in carbon molecules, and after years, sometimes centuries, you release it again with a single match. It's no different from bottling sunlight and then uncorking it on a cold winter evening. But if you keep following this energy trail, the story is far from over, because sunlight isn't the original source of light. The sun's energy comes from nuclear fusion, where hydrogen in the core fuses into helium, releasing energy according to the famous equation, E=mc², and the hydrogen in the sun came from the Big Bang, an event that happened 13.8 billion years ago. That means when you look at a fire burning in the fireplace, you're looking at light that originated in ancient stars, light that once crossed intergalactic space, then got trapped in a leaf, then became the molecular structure of wood, and now is being returned to the universe as dancing orange photons. Among the more than 5,000 exoplanets NASA has confirmed, we have not yet seen any other system with photosynthesis, free oxygen, carbon stored in a biosphere for millions of years, or conditions stable enough for fire to burn sustainably. So fire, the thing you think is ordinary, is actually the final product of a chain of physical and biological conditions, so rare they're almost unimaginable. Volcanoes produce CO4. Plants split CO4s with photons. Carbon is stored. Oxygen accumulates in the atmosphere. And humans burn that carbon to release ancient sunlight back into space. If even one link in that chain were missing, fire would never have appeared on Earth. And that's why I often say fire is not just combustion. Fire is the light of ancient stars, reborn a second time in an energy cycle that can only occur on a planet as strangely special as Earth. I once told my students that if you want to find the single most eccentric molecule in the entire observable universe, don't look far. Just look at the glass of water in front of you. Water does things almost no other substance does. And it does them so delicately that if it were even slightly different, Earth would have been a dead planet billions of years ago. Let's start with the most familiar paradox. Water expands when it freezes. It increases in volume by about 9%. That sounds ordinary, but it's actually anti-physics compared to most substances on Earth. Normally, when something cools, its molecules lose energy, pack closer together, and take up less space. But with water, Higgs molecules form hydrogen bonds in an open hexagonal lattice structure, causing it to take up more volume when it becomes ice. This causes ice to float on the surface instead of sinking to the bottom. And that tiny detail, which seems unimportant, keeps Earth's oceans from freezing solid. If ice sank, The seafloor would freeze first. Thick ice would keep accumulating. Sunlight couldn't penetrate. Photosynthesis couldn't occur. Deep sea life would be wiped out, and the entire ocean would turn into a permanently dead block of ice. In other words, if water behaved normally, Earth would be dead. But water isn't normal. Water's specific heat capacity is 4.18J/G degrees C, the highest of all common liquids. That means water absorbs huge amounts of heat before warming up and releases huge amounts before cooling down. It's a gigantic buffer, an incredibly efficient climate stabilizer. Thanks to the oceans, Earth's average temperature doesn't swing wildly between day and night, or summer and winter. Because of that, life doesn't get scorched or frozen when climate shifts. I often say, water doesn't just quench your thirst, it quenches the entire planet. Then there's water's surface tension, about 0.072 N, unusually high. This allows water to form droplets, flow in streams, collect into rivers, rise into clouds, and fall as rain. One water molecule pulls the next, and the next, creating phenomena we take for granted, but are actually extremely rare in physics. Water droplets hanging on leaves, continuous flowing streams, spherical raindrops falling through air. All of that happens only because water has an oddly strong intermolecular attraction. And do you know what's even stranger? To this day, across humanity's entire catalog of observed planets, from NASA and ESA probes to the most powerful ground and space-based telescopes, we have never observed liquid water existing naturally on the surface of any other planet or moon. We've seen ice, we've seen vapor, we've seen methane oceans on Titan, sulfuric acid rain on Venus, and even signs of subsurface oceans beneath the ice of Europa or Enceladus. But liquid water on the surface, under an open sky, only here, only Earth, and that is not a coincidence. Liquid water exists only in an extremely narrow temperature band, and under pressures that Earth provides exactly. Deviate even slightly, as on Mars or Venus, and water vanishes instantly, either boiling away, freezing solid, or being broken apart by radiation. Water is the center of all life chemistry. It dissolves nutrients, shuttles electrons, stabilizes chemical reactions, provides the environment for proteins to fold, for DNA to replicate, for cells to exist. It is the universal solvent of life because it is sticky, yet flexible, highly polar, yet thermally stable, forms bonds, yet also breaks them. No other molecule in the universe does all of that at once. So when I hear someone say, life could be very common, I usually ask back, do you have any other molecule as strange and perfect as water? If not, then what would life rely on? And that's when they go quiet and think. You see, from fire to oceans, from light to the water cycle, everything revolves around H-how-O, from water vapor forming clouds, to water droplets feeding trees, to floating ice protecting the oceans. Water is the foundation of everything alive, and if water became dense like rock when it froze instead of expanding, Earth would be dead. No exceptions. Once again, not normal at all. Once you've seen how strangely water behaves, you'll start to realize something even more delicate. All that weirdness only works because Earth sits in an unbelievably fragile temperature range. Imagine this: all the carbon-based life we know, from bacteria to humans, can only exist stably between about 0 degrees Celsius and roughly 60 degrees Celsius, a temperature band less than 60 degrees wide, narrower than the daily temperature swing on some other planets. If Earth's average temperature were just above 60 degrees Celsius, proteins would denature, enzymes would stop working, DNA would break down, and every living cell would collapse. If it stayed below 0 degrees Celsius for long periods, water inside cells would freeze. And since freezing water expands, the cells would burst apart. Yet somehow this planet maintains an average temperature of about 14.9 degrees Celsius, a number almost perfectly ideal for what life could ask for. That is not random. It is a balance achieved through a series of exquisitely tuned processes, from orbital distance, axial tilt, heat-absorbing oceans, to atmospheric composition. If even one of those factors shifted just slightly, Earth would become either a frozen ice world or a gigantic furnace. Let's start with a fact few people know. Without the natural greenhouse effect, the very thing many people only think of as bad, Earth today would be an ice-covered planet with an average temperature of 18 degrees Celsius, so cold that the oceans would freeze solid. Water vapor would vanish from the atmosphere, and the water cycle would collapse. No clouds, no rain, no rivers, no biosphere, a silent, dead Earth. We could not live on such a planet, and neither could any organism. But thanks to just the right amount of greenhouse gases, CO5, methane, water vapor, the planet warms by about plus 33 degrees C, lifting the temperature from 18 degrees Celsius to nearly 15 degrees Celsius. You have to understand that 33 degrees Celsius is not a small number. It is the difference between a planet with liquid oceans, green forests, white clouds, and mornings when you open the door and feel the breeze, and a completely frozen, dark, lifeless world. And what's even stranger is that this temperature has remained stable for millions of years, even though the sun is steadily getting hotter. The sun today is about 30% brighter than it was when life first appeared, around 3.5 billion years ago. Yet Earth's temperature has stayed within the allowable range. Without the delicate regulation of the atmosphere, oceans, and biological feedbacks, life would have gone extinct long ago. I want you to pause for a second and really imagine this. The universe you live in, as measured by the cosmic microwave background, has an average temperature of 2.725 Kelvin, just 2.725 degrees above absolute zero. The entire space between galaxies is a near perfectly dark, cold void where molecules barely move. That cold would instantly freeze anything you've ever known, including your own body, solid like granite, the moment it was exposed. In that context, the fact that a tiny planet orbiting a G-type star sits at just the right distance to maintain an average temperature of 14.9 degrees Celsius is truly a cosmic anomaly. On Venus, you would be roasted at 460 degrees Celsius, hotter than a household oven. On Mars, you would freeze at an average of 63 degrees Celsius, with nights dropping to 140 degrees Celsius. On Jupiter's moon, Europa, a subsurface ocean may exist beneath the ice, but the surface is 160 degrees Celsius. Nowhere is stable, mild, and gentle to life the way Earth is. But what fascinates me most is not the numbers. It's how perfectly just right every single factor is timed and placed. Earth's distance from the sun is 1 AU, but shift that by just 5%, and the planet would either boil its oceans away or freeze permanently. The 23.5 degrees axial tilt creates seasons, distributing heat evenly across the surface. No tilt, extreme hot and cold. Too much tilt, chaotic climate. Then there's the 3.7 kilometers deep ocean acting as a gigantic thermal buffer, preventing the planet from becoming a desert or an ice sheet. Everything orbital shape, atmospheric composition, axial tilt, the very existence of oceans aligns so precisely that it forces you to wonder, how does a planet end up in such a fragile configuration? In a universe that is almost entirely frozen, there are only a few warm spots scattered around stars, and among those warm spots, very few have temperatures suitable for liquid water. And among those with liquid water, almost none maintain stable temperatures for billions of years. Yet Earth somehow landed right in the Goldilocks temperature zone, precisely tuned, precisely stable, precisely long-lasting enough for life, not only to appear, but to evolve, diversify, grow complex, and eventually produce creatures capable of observing their own planet. When I look at that, I can only say nothing about Earth is normal, especially its temperature. And if Earth's temperature only exists within an almost absurdly narrow range, then there is another factor that keeps that narrow range from being disrupted every time the sun changes, even slightly, or the planet absorbs more or less light in different seasons: the ocean. It is no coincidence that when astronauts look at Earth from space, they call it the blue marble, because 71% of the planet's surface is covered by water, and that water layer doesn't just exist for show. It is a climate-stabilizing machine that the universe rarely has the luck to possess. When you look at the ocean, you're not just seeing a vast body of water. You're looking at a natural thermal regulation system, so sophisticated that no human technology has ever replicated it. Let's start with the numbers. The average depth of the ocean is about 3.7 kilometers. That means the entire sea forms a thermal blanket thicker than any atmosphere humans can imagine. And with water's high specific heat capacity, the ocean can hold about 1,000 times more heat than the atmosphere. If the atmosphere is the planet's outer paint layer, the ocean is the massive steel framework holding everything stable. Every cubic meter of seawater can absorb heat that hundreds of cubic meters of air couldn't store. Because of this, when the day heats up under sunlight, the ocean soaks up most of that heat without warming too much. When night falls, the ocean slowly releases heat, preventing the planet from plunging into deep cold. Without the ocean, Earth would scorch during the day and freeze at night, like Mercury, where temperature swings can reach 600 degrees Celsius in a single rotation. The ocean does this not only by absorbing heat, but also by transporting it. The thermo-Holland circulation, a global conveyor system moving about 1.3 question-half of water per hour, acts like a gigantic belt connecting all the oceans. Warm water from the equator drifts toward the poles. Cold water from the poles sinks to the depths and flows back toward the equator. This process runs continuously, like the planet's breathing. If you've ever wondered why Europe is warmer than Canada at the same latitude, the Gulf Stream, a branch of the thermo-Holland system, is the answer. It carries heat from the Caribbean all the way to Western Europe, keeping London from becoming as frigid as Alaska. What's strange is that this cycle is extremely sensitive to changes in salinity and temperature. Shift those two parameters just a little, and the whole circulation can shut down, causing abrupt global climate shifts. Yet for tens of thousands of years, the ocean has maintained its stability long enough for human civilization to develop. Imagine a day when the ocean stops regulating. Winters would become so harsh that ice would cover hundreds of millions of square kilometers of land, and summers would scorch the ground until every complex organism dried out and died. Without the ocean, Earth's climate would swing wildly. Simple single-celled organisms might survive that, but advanced life, animals, plants, humans, absolutely could not. Even the evolution of intelligence requires a stable environment lasting millions of years. The ocean is the cradle that kept this planet quiet enough for life to experiment, fail, adapt, and evolve. And if you look out into the universe, you'll see that the existence of a surface ocean is extraordinary. Titan has liquid methane seas, so cold that no protein could function. Europa and Enceladus may have subsurface oceans, but they are locked beneath tens of kilometers of ice. Mars once had an ocean, but it couldn't hold its atmosphere and lost its water to space. Earth not only has a liquid ocean, but a stable, continuous ocean that transports heat, nurtures life, influences climate, and has existed for at least 3.8 billion years. No phenomenon observed among exoplanets shows that kind of long-term stability. And here's the key point. The ocean doesn't exist in isolation. It works together with the atmosphere, the sun, orbit, axial tilt, clouds, polar ice, forming a delicate feedback mechanism. The ocean absorbs CO2, generates rain, feeds phytoplankton, the organisms that produce more than 50% of Earth's oxygen. That means the ocean doesn't just control climate. It creates the very air you breathe. From a physics perspective, the ocean is the ultimate condition, making Earth abnormally stable. Without the ocean, this planet would be like thousands of anonymous worlds out there, scorching hot or paralyzed cold. Chaotic atmospheric swings and complex life would never have had a chance to emerge. And so, in the moment you stand on the beach, watching waves roll in, you're not just looking at water, you're looking at Earth's regulating heart, the climate stabilizing machine. The universe rarely repeats. The ocean is the reason Earth is alive, and the clearest proof of the story I'm telling you. Earth is stable to an abnormal degree. You cannot talk about Earth's strange stability without mentioning the element behind every living thing you've ever known. Carbon. If the ocean is the machine keeping this planet alive, then carbon is the building material that allows life to exist in countless forms. In the periodic table, no element is as versatile as carbon. It can form roughly 10,000 different molecular structures, a number so large that if you spent your entire life writing one structure per second, you wouldn't even scratch the surface. It is precisely this chemical flexibility that makes carbon the foundation of life, and also the reason no other element can replace it. Carbon has 4 valence electrons and forms tetrahedral bonds, creating strong yet flexible structural networks. Because of this, carbon can form long chains, rings, 2-dimensional lattices, 3-dimensional networks, branches, helices, layers. Almost every structure life needs to store information, or catalyze reactions can be built from carbon. DNA, the molecule that encodes life, is built on a carbon backbone. Proteins, the tools that execute every function in the body, are based on carbon. Cell membranes, hormones, enzymes, carbohydrates, lipids, all are products of carbon chemistry at its most fundamental level. Biology is carbon organizing itself, and what makes carbon even more extraordinary is its origin. Carbon does not form in small explosions or inside planets. It is born in the hearts of massive stars, where temperatures are high enough for the triple alpha process to fuse 3 helium nuclei into 1 carbon atom. But this process only occurs in large, short-lived stars that end their lives in supernova explosions. When those stars detonate, they scatter carbon, oxygen, nitrogen, iron, and a host of other heavy elements into interstellar space. Tens of millions of years later, those dust clouds collapse and form new planetary systems. That is the origin of our solar system, a cloud containing the ashes of multiple generations of earlier exploded stars. When you hold a leaf in your hand or look at a tree trunk, you're not just looking at living material. You're looking at remnants of stars that died more than 4.6 billion years ago. The carbon on Earth did not originate on Earth. It came from places thousands of light years away, forged in stellar cores under unimaginable pressure and heat. Then it drifted for millions of years through space, gathered in molecular clouds, fell into a young protoplanetary disk, mixed with water, rock, and other compounds to create the blue planet you stand on. Without carbon on Earth, there would be no DNA, no proteins, no cells, no plants or animals, no intelligence, no form of life as we know it. Silicon-based life, often mentioned in science fiction, is in reality not feasible because silicon cannot produce the molecular diversity carbon achieves. It can form tens of millions of compounds, but not 10. It cannot create the flexible structures carbon does, cannot enable protein folding mechanisms, cannot form stable DNA, cannot sustain the metabolic networks life requires. Among the thousands of planets NASA and telescopes have observed, none show evidence of stable carbon-based chemistry in an environment with liquid water. Even just having carbon, liquid water, and suitable temperature together is so rare it is nearly absent from current exoplanet samples. Earth is not merely lucky. It received the foundational element of life thanks to generations of stars that exploded long before this planet formed. Every carbon atom in your body was once inside the core of a dead star, a detail that always makes me see life on Earth as both tiny and majestic. When you exhale CO4, you are releasing carbon that was once forged in the furnace of a supernova. When you eat an apple, you are swallowing sunlight stored in carbon molecules, and that carbon came from an exploded star. Every molecule in your body was once stardust, literally. Carbon is the origin of life, but it is also a reminder that Earth is not a random speck in the universe, but the result of cataclysmic stellar deaths and the rebirth cycles of stellar generations. A planet capable of gathering supernova ash, mixing it with liquid water, a stable atmosphere, and suitable temperature to produce complex life is so rare it is almost unbelievable. Earth was born from the ashes of exploded stars, and that makes it extraordinary in a way no words can fully capture. When you look up at the sun, you might think it's just an ordinary star, a glowing ball of plasma, nothing special. But if you are a creature that needs energy to survive, and if you look at it through the eyes of physics, then our sun is not normal at all. In fact, it is so rare, it is almost a cosmic miracle. Its surface temperature is about 5,700 Kelvin, and that exact number determines the kind of light it emits most strongly, around 500 nanometers, right in the middle of the visible spectrum. This is not just an interesting physics fact, it is the foundational piece for all life on Earth. Consider what happens when life evolves under such light. Leaves, through pigments like chlorophyll A and B, absorb light most strongly in two completely different regions, around 430 nanometers, violet blue light, and 660 nanometers, red light. The middle part, roughly 550 nanometers. They barely absorb at all. They reflect that part. And that part is the green light your eyes see. So what fascinates me is not just that leaves are green, but that the sun's light spectrum matches perfectly with the absorption spectrum of life, even though the two develop completely independently. A star emits its strongest light exactly in the region where organic molecules can harvest it and convert it into chemical energy. A tiny organism finds a way to exploit precisely the energy band the star provides most abundantly. This compatibility sounds obvious until you look at real astronomy. Across the entire stellar population of the Milky Way, stars like the Sun, G, 2V type, make up only about 7%. Most stars are smaller, cooler, redder. They shine weakly, with most of their light in the infrared, unsuitable for breaking molecular bonds or exciting electrons, the things carbon-based life needs to function. Larger stars are so hot, they emit mostly ultraviolet. With so much energy, it would destroy life as soon as it began to form. In other words, most stars are either too weak, too red, or too dangerous to nurture sophisticated biology like Earth's. But the sun, it sits right in the middle, an extremely narrow zone where the light spectrum is strong enough to drive photosynthesis, but not so strong. It incinerates DNA. an almost freakishly balanced position. And here's something else. If you reran Earth's evolutionary simulation with a different star, photosynthesis would almost certainly never appear. Photosynthesis only exists because the sun's light spectrum happens to match the carbon, hydrogen, oxygen bonds that absorb light at exactly those frequencies. The universe did not design this. It has no blueprint. It had no intention of making green leaves. Yet the random alignment between the radiation spectrum of a rare star and organic molecules created a pivotal physical breakthrough. The first organisms that could use light to feed themselves. About 3.5 billion years ago, cyanobacteria began harvesting red and blue light, precisely the two strongest regions in the sun's spectrum. From there, oxygen rose, the ozone layer formed, complex life developed, and eventually humans appeared. All because the sun happened to emit light in the two regions organic molecules could use most efficiently. Imagine if the sun was slightly redder, like most red dwarf stars. Leaves would have to absorb infrared, energy too weak to break chemical bonds. Photosynthesis might never have arisen. If the sun emitted stronger violet light, like A or B stars, the radiation would destroy every organic molecular structure the moment it appeared. Life would struggle to evolve beyond the just formed and already destroyed stage. Earth exists because the sun is the right type, right temperature, right light spectrum, in the right rare part of the galaxy. Only 7% of stars are this type. And even among them, not all remain stable for billions of years like the sun. Some vary strongly in brightness. Some have flare cycles. Some spin fast and generate overly strong magnetic fields. If you wrote a minimum requirements list for carbon-based life to appear, you would see the sun meets almost every criterion without even trying. Light in the visible range, stable over billions of years, mass just right to evolve, neither too fast nor too slowly, light neither too weak nor too harsh. This makes Earth rare, not just because it has water or an atmosphere, but because it orbits a very particular kind of star, ideally suited to nurture complex biology. From a physics perspective, that is almost an absurd coincidence. Life on Earth depends on a rare star type and a rare light spectrum, an arrangement that no planet we have observed to date possesses. When you look at a leaf, you probably don't think you're looking at one of the most sophisticated quantum machines that has ever existed in the universe. But that is exactly what is happening. After sunlight, that rare light we just talked about strikes the leaf inside the chloroplast. A sequence of processes unfolds that, if I described it to a quantum engineer, he would think I was talking about future technology. But no, it is the technology of plants, and it has existed for more than 3 billion years. The first step in photosynthesis is the absorption of a photon, creating an exciton, an excited energy state that can travel through the molecular network inside the chloroplast. What is astonishing is that this exciton does not move in the classical way, like a marble rolling through a maze. It uses phenomena that only quantum physics can explain: coherence and tunneling. You can picture it like this. Instead of slowly trying one path after another, the exciton spreads itself like a wave, simultaneously exploring every possible path through the molecular structure. It knows which path is shortest, because quantum interference cancels out the inefficient paths and amplifies the optimal one. The result, it selects the very best path almost instantly. No human supercomputer works this way. And when the scientists at Fleming Lab measured this mechanism in 2007, they could hardly believe the numbers. Energy transfer efficiency reached from 95% to 99%, a level of performance that even the most optimized artificial energy systems cannot approach. A leaf, something you once thought was ordinary, operates a nanoscale quantum machine better than any solar cell technology we have created. This machine operates in a wet, room temperature environment and is continuously disrupted by thermal vibrations, conditions that our artificial quantum systems struggle to tolerate. So why does nature achieve what humans are still laboring to simulate? Because evolution has fine-tuned this system over billions of years, and contrary to common intuition, the noisy environment at the molecular level sometimes enhances quantum efficiency rather than destroying it. Biology found a way to harness that noise to help the exciton find its path faster. If this sounds like a design trick from high-tech laboratories, it is, but it's being executed by oak trees, weeds, and moss. An exciton travels from the light-absorbing molecule to the reaction center of the chloroplast in just a few trillionths of a second. But that journey is the very first step that opens the entire chain of reactions, producing oxygen, glucose, and the chemical energy that sustains the planet. Without that journey, there would be no animals at all, no herbivores, no carnivores, no coral, no birds, no whales, no humans. The universe would have no free oxygen in the form we breathe. Oxygen is the byproduct of a chemical accident that life stumbled upon, an accident that changed the entire Earth. Before oxygenic photosynthesis appeared, about 2.4 billion years ago, the atmosphere had almost no oxygen. But in just a few 100 million years of activity, chloroplasts, or more precisely, their ancestors, cyanobacteria, released enough oxygen to create the ozone layer, oxidize the oceans, and pave the way for complex life to develop. What is extraordinary is this: the very first step of that process was a quantum event, an exciton jumping from one molecule to another through a mechanism we have only understood in the last 2 decades. When you read in the news about quantum computers, you may think that is the pinnacle technology of the 21st century. But it turns out the tree in your backyard has been using quantum algorithms since before Earth had oxygen for you to breathe. And that brings me to the most important point. Without photosynthesis, no multicellular form of life would ever have appeared. No Amazon rainforest, no animals, no human brain, no civilization. Earth is not just beautiful or lucky. It possesses a quantum machine inside a leaf, something the universe has refined over billions of years to convert the light of a rare star into the life you see all around you. In most of the universe, energy is scattered, cold, and unharvestable. But on Earth, a single leaf can turn every photon into life. If that is not extraordinary, then I truly don't know what normal is anymore. No part of Earth makes me feel it is normal. But if there is one thing that almost tricks you, because it is so silent, so stable, so invisible, it is Earth's magnetic field. We live right inside a gigantic physical marvel, a machine that has operated continuously for nearly 4 billion years without anyone seeing it. No sound, no light, no warning. Yet it determines whether we can breathe, whether we have oceans, whether we have an atmosphere at all. And if it disappeared, Earth would become a dead planet faster than you think. Let's start beneath your feet, about 2,900 kilometers down, at the boundary between the mantle and the outer core. There exists a vast ocean of molten metal, mostly iron and nickel, at temperatures of about 4,000, 6,000 degrees Celsius, nearly as hot as the surface of the sun. This liquid iron mass moves constantly due to convection and Earth's rotation. That motion generates a phenomenon called the geodynamo. You can imagine it as a natural electric generator, except that its copper wire is liquid iron, and its electric current is gigantic swirling motion. The result of the geodynamo is Earth's magnetic field, with a strength of about 2565 microtesla at the surface. That number sounds weak, but it creates a gigantic magnetic bubble surrounding the planet, stretching more than 60,000 kilometers toward the sun, and with a tail hundreds of thousands of kilometers long on the opposite side. This invisible shield, the magnetosphere, is the reason Earth is not blown away by the sun. Yes, I mean literally, blown away. The sun is not the gentle source of light that poetry describes. It is a nuclear fusion reactor, firing out the solar wind, streams of plasma made of high-energy electrons and protons traveling at 400, 800 kilometers per s. Without a magnetic field, the solar wind would strip the atmosphere away, molecule by molecule. This is not theory. This is exactly what happened in our own solar system, to a planet everyone once hoped had life, Mars. In 2015, NASA's MAVEN spacecraft provided direct evidence that Mars once had a thick atmosphere and liquid water flowing on its surface, and then lost everything simply because it had no protective magnetic field. MAVEN measured the rate at which Mars's atmosphere was stripped during solar storms. Every second, hundreds of grams of gas were blown away. When Mars's core cooled, the dynamo stopped, and the planet lost the only armor capable of holding its atmosphere. In just a few 100 million years, a geological blink, it became the cold, 60 degrees Celsius desert we see today. The blue sky vanished. The oceans evaporated. CO5 was dragged into space by the solar wind. If you put Earth in the same situation, the same thing would happen. Our oceans would begin to be split by ultraviolet radiation. Water hydrogen plus oxygen. The light hydrogen would quickly escape to the upper atmosphere and be swept away by the solar wind. No more hydrogen. No more new water created. The oceans would dry up. The ozone layer would disappear. Life would face direct radiation and vanish. We escaped that fate because Earth possesses an extraordinarily persistent geodynamo. And that leads to an interesting question. What allows Earth to maintain a strong magnetic field for 4 billion years, while other rocky planets could not? For a geodynamo to operate, a planet must have a liquid outer core thick enough for convection, a solid inner core to create a crystallization effect that releases heat, a fast rotation period, 24 hours is ideal, a large enough size to retain heat for billions of years, a gigantic temperature difference from core to surface. Let's check the neighboring planets. Mercury, too small, core cooled quickly, magnetic field, too weak to protect any atmosphere. Venus rotates extremely slowly, 1 day equal sign 243 Earth days. Dynamo barely functions. Mars core froze too early, magnetic field collapsed. Among all the rocky planets we know, only Earth has maintained a strong and stable magnetic machine for such an immense period of time. This is surprisingly rare among the thousands of exoplanets discovered. The number of rocky planets showing evidence of a strong geodynamo is almost zero, because sustaining core dynamics for billions of years requires a balance of size, rotation speed, structure, and chemical composition, all conditions that are extremely unlikely to occur together. And I want you to remember this. Every time you see the aurora, you are not just looking at a beautiful phenomenon. You are looking at the boundary between life and destruction. Those dancing green, red, and purple colors are the traces of high-energy particles being bent by the magnetic field, instead of slamming straight into the ground and destroying the DNA of every living thing. The magnetic field holds the atmosphere in place. The atmosphere holds the oceans in place. The oceans keep the climate stable. A stable climate keeps life existing, and all of it depends on a river of liquid iron, 3,000 kilometers beneath your feet, swirling like the metallic heart of the planet. A planet with a dynamo core like that is extremely rare, almost absurd. But we are standing on exactly that planet. Earth is never normal, and its magnetic field is one of the clearest pieces of evidence. When talking about Earth's abnormality, we cannot overlook the quietest, most enduring yet strangest companion of this planet, the moon. If the magnetic field is Earth's invisible armor, then the moon is the gigantic rudder that keeps this planet from rocking into chaos. And the most astonishing thing is the moon should not exist according to any conventional planetary formation model. First, consider the moon, Earth-size ratio. The moon has a diameter of about 3,474 kilometers, which is 27% of Earth's diameter. This is one of the largest ratios in the entire solar system, almost absurd. If you shrank the solar system down, all moons would be tiny peas orbiting their parent planets, except our moon, which is practically a second planet. Among more than 200 moons observed in the solar system, none is as large relative to its host planet, except Charon of Pluto. But Pluto is not a rocky planet like Earth, and it is precisely this giant ratio that has given Earth stability in a way no other planet has achieved. Thanks to the moon, Earth's axial tilt, 23.5 degrees, has remained stable for millions of years. Without it, the axis would wobble strongly due to the gravitational pull of the Sun, Jupiter, and the uneven mass distribution inside Earth itself. Mars has no large moon, and its axis has wobbled from 0 degrees to over 60 degrees throughout its history, leading to extreme climate swings, complete ice melting, then refreezing, an environment very difficult for complex life to maintain long term. Earth avoided that fate because the moon acts as a counterweight, stabilizing the planet's rotational motion. Without that stability, we would have no predictable climate, no stable seasons, no environmental cycles that biology could evolve along. But the moon's influence does not stop at axial stability. Tides are a crucial node in the story of life. About 3.5 billion years ago, when the first life was still fragile cell membranes in the primordial ocean, tides created intertidal zones, nutrient-rich areas with slow temperature fluctuations and rhythmic changes in salinity. Many biological hypotheses suggest that these strong tidal zones drove the polymerization of organic molecules, helping the first RNA chains form. Some models even propose that early multicellular life developed in shallow waters, constantly agitated by tides, much stronger than today's, when the moon was about twice as close to Earth as it is now. You can imagine, no moon, no strong tides, no alternating wet, dry environment, no initial evolutionary processes as we know them. And all of this stems from an even more absurd event, the Theia impact. About 4.5 billion years ago, a Mars-sized body, which scientists call Theia, collided with the young Earth. The impact was so massive that it melted the crust, blasted material into orbit, and eventually formed the moon. This event is extremely rare. Simulations show that most impacts of that scale would either destroy the planet or eject material insufficient to form a stable moon. The fact that a collision produced a moon large enough to stabilize a planet's rotation, yet did not destroy the planet, is a chain of luck almost unimaginable. But it is precisely that unimaginable event that created the Earth you live on. The moon also slowed Earth's rotation. In the early period, a day on Earth was only about 6 hours. Tidal friction gradually dragged Earth down, lengthening the day to 24 hours. A perfect cycle for biological rhythms, from plants to animals, every system relying on this 24-hour beat. Imagine life having to exist on a planet with 6-hour or 60-hour days. Climate would fluctuate more. Day, night temperature differences would be greater. Biological cycles would be far harder to stabilize. And everything you consider normal, oceans rising and falling, seasons changing regularly, life evolving steadily for billions of years, is the result of a moon so large it resembles nothing we have ever seen in other moons. When you look at the moon, you are looking at the remnant of a terrifying cosmic collision, the very thing that helped Earth become the only planet we know with complex life. Its existence is an absurd coincidence, and the only logical conclusion is, without the moon, Earth would not be stable enough to develop life. If the moon keeps Earth stable from within its rotational motion, then the planet's orbit keeps everything stable from the outside, as if the entire solar system were designed to create a narrow band where life can exist. People call it the Goldilocks zone, the just right zone. Not too hot, not too cold, not too close, not too far. And what always amazes me is that Earth does not just lie in the Goldilocks zone. It sits right in the exact center of that band. The only way to see this clearly is to look with the eyes of physics. First, consider Earth's orbital eccentricity, only 0.0167, a value so small it is almost a perfect circle. Most planets we observe in other stellar systems have significantly eccentric orbits, elliptical, causing extreme swings in distance from their host star. For those planets, a year might start in ice and end with oceans boiling away a few months later. Earth is different. It maintains a distance variation of only 3% around the average, small enough for climate to remain stable for millions of years. Without this near-circular orbit, ice ages could stack upon ice ages, or extreme heat could scorch biology. But we sit in an orbit so smooth that civilization could build itself upon it. Where is that orbit located? At 1 AU, about 150 million kilometers, a distance that seems arbitrary but is a magical balance point between two physical extremes. If Earth were 5% closer to the sun, water would evaporate, the greenhouse feedback would run away, and the planet would become a second Venus, 460 degrees Celsius. If 5% farther, water would freeze globally, CO hold would condense, and the ice albedo feedback would lock Earth in permanent ice. Many planets in the abstract Goldilocks zone lack liquid water because their unstable orbits swing them between these two extremes. Earth, once again, sits at the tiny central point where physical factors balance perfectly. But there is another, even subtler factor that always fascinates me. The stability of the solar system is not natural. It comes from the role of the giant planets, especially Jupiter. Jupiter has more mass than all the other planets combined. Its gravity acts like a cosmic vacuum cleaner. Many simulations show that Jupiter has deflected or swallowed countless asteroids, comets, and objects tens of kilometers in size throughout 4.6 billion years. Without Jupiter, those objects would strike Earth at a frequency dozens of times higher. We have seen what happens when a single asteroid, about 10-12 kilometers in diameter, hits a planet. The Chicxulub event 66 million years ago wiped out 75% of species, including the dinosaurs. Biology needs a stable environment for hundreds of millions of years to evolve from single cells to complex brains. If large impacts occurred more frequently, complex life would never have had a chance to appear. Jupiter, with its gravity, serves as a silent gatekeeper. And it is not just Jupiter. Saturn, Uranus, and Neptune also help regulate orbital resonances, giving the solar system a durable, stable structure, something exceedingly rare among the more than 5,000 planetary systems we have observed. Most planetary systems are chaotic. Planets collide with each other, plunge into their star, or have orbits that swing violently for millions of years. Earth exists in the Goldilocks zone, not only because of suitable distance, but because its orbit has remained stable for billions of years. Something so rare, it is hard to believe on a cosmic scale. In long-term dynamical simulations, our solar system is considered one of the most gentle configurations scientists have ever seen. And it is precisely this gentleness that created an environment where life could not only appear, but evolve continuously without interruption. When you look at sunlight through the window or feel the wind on your face, you are feeling the effect of a gigantic chain of balances, a stable star, a nearly perfect orbit, an absolutely ideal distance, and an army of giant planets shielding asteroids in the dark. All of those things had to happen simultaneously. A small change, even one so tiny you think it doesn't matter, could turn Earth into a frozen dead planet or a second Venus. But what is astonishing is this Earth has not just been stable for 10 million or 100 million years. It has been stable for 4.6 billion years, long enough for life to evolve from molecules to intelligence, from RNA to spacecraft, from bacteria to humans. When you hear the phrase, Earth is in the right place at the right time, understand that it is not a poetic saying. It is the most accurate physical description of a planet that had no reason to be this perfect, yet somehow it is. Earth is in the right place at the right time throughout its entire history, and that is why it cannot be an ordinary planet. If the Goldilocks orbit is the perfect stage for life, then Earth's geochemistry is the orchestra playing exactly the right melody. And the remarkable thing is that no planet among everything we have observed has a similar arrangement. When you take a really deep breath, you are inhaling a mixture of gases that the universe rarely produces. 78% nitrogen, 21% oxygen, and the rest argon, CO4, water vapor, along with traces of dozens of other gases. Abundant nitrogen stabilizes the atmosphere because it is chemically inert and does not easily react. Oxygen, the byproduct of photosynthesis, sustains aerobic life. Those two numbers, 78% and 21%, are not random. They are the result of billions of years of balance between geology, biology, and climate. What is unusual here is that no planet outside Earth that we have observed possesses a similar gas mixture. Mars has 95% CO4 and almost no oxygen. Venus has 96% CO4 with pressure 92 times that of Earth. Titan is rich in methane. Triton has nitrogen, but in a frozen state. Nowhere is there a nitrogen-oxygen pair like Earth's, let alone the perfect ratio for aerobic life to exist. In fact, free oxygen is the strongest biosignature. It cannot persist long unless it is continuously replenished. And that is exactly what green plants have been doing for 2.4 billion years. But the atmosphere is only one part of the geochemical story. Look at the composition of the planet itself. According to the PREM model, Preliminary Reference Earth Model, iron makes up 32.1% of Earth's total mass, an enormous figure that determines many of the planet's physical properties, from density and gravity to the ability to generate a dynamo in the core. If Earth lacked sufficient iron, the magnetic field would be hard to sustain. If it had too much iron, the planet might be too dense and too hot to maintain a stable crust. Earth sits exactly at that balance, a rare geochemical configuration. But what strikes me as strangest is not the ratios of the elements, but their coordination. Earth has an iron-rich core, a magnesium and silicate-rich mantle, and a light mineral-rich outer crust, all of which together create plate tectonics that no other rocky planet in the solar system possesses. Mars once had volcanic activity, but died long ago. Venus may have convection, but its crust does not break into plates. Only Earth has the cycling of the lithosphere and continental plates, a continuous process that renews the surface, creates mountain ranges, shallow seas, coastlines, and chemical cycles that nourish life. An ordinary planet is not recycled from the inside out like this. Earth is. Let us go higher into the stratosphere. At altitudes of 1535 kilometers, there is a tiny but vitally important layer, ozone. The ozone layer absorbs almost all UVC and most UVB, the two types of radiation that can destroy DNA in just seconds. Without ozone, every cell on the surface would be killed by solar radiation before it could even divide. What is interesting is that ozone is not a default planetary feature. It exists on Earth only because free oxygen exists, and free oxygen exists only because of photosynthesis. Ozone is not a natural layer like Venus's CO fission atmosphere. It is a byproduct of life. Life creates ozone, and ozone protects life. A feedback loop so delicate that if oxygen dropped to 15%, the ozone layer would thin to dangerous levels. Another planet with oxygen, not found yet. A planet with ozone, also not found. And now, back to the ground. Look at the tiniest dust particles under your feet. Soil dust contains rare earth minerals, lanthanides, thorium, zircon, hafnium, elements that are rare but play critical roles in enzyme development, energy metabolism, protein structure stabilization, and even the evolution of ancient organisms. These minerals come from ancient meteorite impacts and from plate tectonics that bring deep material to the surface. Not every planet has this complex mixture. Not every planet has a mineral recycling cycle to nourish life. Not every planet has regular volcanic activity that releases CO2, but not so violently that it destroys the climate. Earth's geochemistry is a multi-layered symphony. Nitrogen in the atmosphere stable, but non-toxic. Oxygen high enough for aerobic life to breathe, but not so high as to cause global fires. Carbon just right to regulate temperature, but not enough to cause runaway greenhouse. Rare earth minerals, just enough to drive sophisticated biochemical reactions. And ozone, the thinnest membrane of them all, shields the entire planet from ultraviolet radiation. Every element in this system depends on the others. If nitrogen dropped by 20%, the atmosphere would lose stability. If oxygen rose to 30%, global fires would become frequent. If carbon were halved, Earth would fall into ice ages. If there were not enough iron in the core, the magnetic field would stop. If there were no magnetic field, the atmosphere would be stripped away. Everything from dust particles to the ozone layer to the molten iron core works together to create a planet capable of nurturing life and keeping it alive long enough to evolve. If geochemistry forms Earth's orchestra, then the biosphere is the conductor directing the entire concert, a system that from everything we have observed, no other planet in the universe has ever shown anything like it. The biosphere is not just living organisms. It is the totality of life, from bacteria in the soil, phytoplankton in the sea, forests, grasses, animals, all the way to humans themselves. And all of them interact with the atmosphere, oceans, and geology in a way that has turned this planet into a self-regulating machine, operating for 3 billion years. No non-biological system has remained stable that long. Consider the carbon, nitrogen, oxygen cycle, the foundation of all life. Carbon moves from atmospheric CO2 into plants via photosynthesis, becomes sugars, then enters animals when they eat plants or other animals. When those organisms respire, carbon returns to the atmosphere. When they die, bacteria decompose them, sending carbon into the soil or ocean floor, where it can be locked away in limestone or sediments for millions of years. Nitrogen, which makes up 78% of the atmosphere, but is unusable directly by most organisms, is fixed by soil bacteria and cyanobacteria in the sea, turning it into ammonia and then nitrate for plants to absorb. When plants are eaten, nitrogen enters animals. When animals excrete or die, nitrogen returns to soil and sea, and eventually back into the atmosphere as gas, closing the loop. Oxygen, the product of photosynthesis, enters the air, where animals breathe it and turn it back into CO2, which plants use again to produce oxygen. A system that runs rhythmically, durably unbroken, for so long that the universe is unlikely to repeat it. But what amazes me most in this entire story is the very origin of oxygen itself. People often think land plants are the lungs of the planet, but the truth is 50% of Earth's oxygen comes from marine bacteria, especially cyanobacteria, and photosynthetic plankton. Tiny organisms you cannot see with the naked eye are the most powerful force maintaining the atmosphere you breathe every day. The ocean, covering 71% of Earth, is the silent, steady, tireless oxygen factory that has run for more than 2 billion years. And what is even more interesting is that life does not merely use oxygen. It regulates its amount. If oxygen exceeds about 25%, the planet risks global fires because organic material would ignite far more easily. If oxygen falls below 15%, large animals cannot extract enough energy from respiration to survive. But Earth, it has held oxygen around 21% for hundreds of millions of years. That is not coincidence. That is dynamic stability, a self-regulating state where organisms, climate, and geology continuously feed back on each other to keep life within the safe zone. Forests act as gigantic photosynthetic machines, but also as thermal regulators. When CO5 rises, plants grow faster, absorb more carbon, and pull CO5 back down. The oceans absorb CO floor through dissolution and through plankton. Soil stores carbon in organic form, and all of this happens simultaneously, naturally, without anyone in control. You can call it the biological, geochemical, climate feedback loop. I call it one of the most sophisticated, self-operating systems in the universe. In planetary ecological simulations, when we change a single small factor, light levels, CO4, oxygen, nitrogen, temperature, salinity, ocean depth, Earth continues to adjust and return to balance. A dead planet does not do that. Only a planet in which the biosphere has penetrated every nook and cranny can do that. The biosphere does not merely sit on Earth. It operates Earth. It breaks rock into soil, creates clouds through evaporated organic molecules, regulates CO4 via plants and oceans, produces oxygen via photosynthesis, keeps nitrogen cycling through bacteria. And this entire colossal structure, millions of species, trillions upon trillions of chemical reactions every second, has run stably for more than 3 billion years. What I find extraordinary is not just the existence of the biosphere, but its persistent stability. Among other planetary systems we have observed, nowhere shows evidence of such a complex dynamic equilibrium system. No atmosphere elsewhere shows continuously maintained oxygen. No ocean shows biological activity capable of regulating climate. No sign exists of continuous carbon transport between atmosphere, organisms, and rock. Earth does not just have life. It has a life control system, an intricate feedback network that makes this planet operate like a gigantic organism, always adjusting, always adapting, always keeping itself within the range that allows life to persist. No system in the known universe operates in the same way. If the biosphere is Earth's control system, then your own eyes are the most vivid living proof that life has been tuned to the very special conditions of this planet, to the point that I always feel as though evolution has accidentally built a perfect spectrometer for sunlight. Let us start with a simple but physically weighty fact. The human eye is sensitive to light in the 400-700 nanometer range, exactly the region where the sun emits most strongly, not shifted into infrared, not shifted into ultraviolet, but squarely in the golden window of the solar radiation spectrum, right where light energy is high enough to stimulate cells, but not so strong as to destroy DNA. If the sun were cooler, like red dwarfs, most light would be in the infrared. Human eyes or any creatures would have no reason to evolve sensitivity in the 400-700 nanometers range. If the sun were hotter, the strong energy region would lie in the ultraviolet, an environment where biological eyes would struggle to survive because living tissue would be destroyed quickly. But the sun sits in the middle, and our eyes sit in the middle, not by chance, but as the result of hundreds of millions of years of evolution under Earth's specific optical conditions. The retina, the thin layer of tissue, only a few hundredths of a millimeter thick at the back of your eye, contains two types of photoreceptor cells, rods and cones. About 120 million rods allow you to see in low light, sensitive enough to respond to single photons. About 6 million cones allow color vision, distinguishing wavelengths in the range where the sun shines strongest. The three types of cones, sensitive to red, green, and blue, create color discrimination that few animal species possess. What is interesting is that all three cone types have peak sensitivity right in the region where sunlight dominates. Not too long, not too short, not infrared, not ultraviolet, but exactly the region where Earth's atmosphere also transmits light best. That is called the atmospheric optical transmission window, where molecules like nitrogen and oxygen do not absorb strongly, unlike ultraviolet blocked by ozone and infrared absorbed by water vapor. So you have three layers of optimization stacked on top of each other. The sun emits most strongly in the 400-700 nanometers range. Earth's atmosphere transmits best in that range. The human retina is most sensitive in that range. From a physics perspective, this is an extraordinary coordination. From a biological perspective, it is intelligent evolution. And from a cosmological perspective, this coincidence is truly strange. Your eyes are not just a light collector, they are an extremely powerful signal processor. The retina processes up to 10 million bits per second before the signal even reaches the brain. The retina performs most of the computation you think belongs to the brain. It enhances contrast, detects edges, smooths noise, converts photons into electrical pulses, and even predicts motion. In fact, the retina is like a natural neural processing chip, fine-tuned to optimize light coming from the sun and reflected from Earth's environment. Not only that, the human eye sees green better than any other color. This makes perfect sense when you remember that for tens of millions of years, most of Earth's landscape has been forests, trees, vegetation, and leaves reflect strongly in the green region. The ability to finely distinguish many shades of green was a strong evolutionary advantage in such an environment. But let me say this, the human eye is not simply optimized for forests. It is optimized for the radiation spectrum of a rare star and for the atmospheric optical transmission window of a rare planet. If you placed life on a planet orbiting a red dwarf, the most common star type in the universe, most light would be infrared. Eyes would evolve to see infrared, completely different from the biological eyes we know. If placed around a hot white star, biological eyes would struggle to exist because life would have to hide underground or underwater to avoid intense ultraviolet. So why do human eyes see exactly this region? Because eyes evolved not in a vacuum, but in a unique optical environment, one we have not observed anywhere else in the universe. Your eyes are the final product of a chain of physical conditions stretching over billions of years: sunlight in the visible range, an atmosphere transmitting light in the visible range, vegetation reflecting strongly in the visible range, organisms evolving to live under such lighting conditions. The result, the human eye became a tool for decoding the world with accuracy that exists entirely thanks to the abnormal structure of Earth and the sun. When you watch a leaf swaying in the wind, you are using an optical system more sophisticated than most cameras humans have built. If the eyes allow you to see the world in visible light, there is another kind of vision, invisible, far broader, more sophisticated, that human civilization has only learned to use in the last century: electromagnetic waves. And what fascinates me most is that not every planet allows electromagnetic waves to propagate freely, but Earth does. Not only does it, but it has an extremely rare physical gift called the radio window, an atmospheric radio door, a condition so accidental that if you simulated millions of planets, almost none would possess it. Imagine the atmosphere as a gigantic fence. It blocks gamma rays, X-rays, and most ultraviolet. Good, because those things damage DNA. Water vapor and CO4 strongly absorb infrared. Ozone blocks most UVB and UVC. Almost every form of radiation is blocked somewhere. But for some strange reason, Earth's atmosphere is completely transparent to one very special band of waves from about 1 mm to more than 10 meters. This is the radio window. If you change the atmospheric composition just a little, increased water vapor, increased methane, altered pressure, this window would disappear. It is not an inevitable feature of atmospheres. It is an accident of molecular physics and Earth's atmospheric structure. But that very accident has allowed us to do miraculous things, send signals across the planet, talk to satellites in orbit, measure weather with radar, navigate with GPS, connect to the internet with Wi-Fi. All of it rests on the simple fact that the atmosphere happens to have a gap that lets radio waves pass through with almost no absorption. Let me take you a little farther, very far. In the 1970s, NASA launched the 2 Voyager spacecraft. As of today, Voyager 1 is more than 24 billion kilometers from Earth, beyond the heliopause, entering interstellar space. And the wonder is, we can still communicate with it using radio waves. A signal sent from Earth takes more than 22 hours to reach the spacecraft, and the reply takes 22 hours to return. All thanks to one thing: radio waves can pass through Earth's atmosphere without being absorbed and almost without being scattered. If Earth had no radio window, Voyager 1 would be a silent object drifting through the cosmos. No signal could escape. No space mission could operate beyond the atmosphere. Even ground telecommunications would not exist. Modern technology, everything from phones to weather radar to weather satellites to the internet, stands on a physical condition we did not create. We only exploit it. What always makes me smile in an ironic way is that early 21st century electromagnetic physicists believed radio would not work over long distances because signals had to pass through the atmosphere. But then they discovered the atmosphere did not care. It let radio pass as though it were obvious. But no, it is not obvious at all. Imagine another planet, thick atmosphere, like Venus radio, completely absorbed, lots of water vapor, like Titan entire cm and mm waves blocked, low pressure like Mars unstable plasma noise, different gas compositions, absorption bands completely changed. No planet in the solar system has a wide and clean radio window like Earth's. This makes me pause every time I look up at the sky and think we are living on a planet whose atmosphere allows technical civilization to exist. If you look deeper, the radio window has an even subtler role. It allows us to see the universe. Radio astronomy exists because radio from galaxies, pulsars, quasars can penetrate the atmosphere and be captured by antennas. Major discoveries in modern physics, the cosmic microwave background, CMB, pulsars, galactic hydrogen distribution, all came through this window. Without it, we would be blind to most of the universe. And the most beautiful truth in this story is that Earth was not designed for radio. The atmosphere did not intend to be transparent. The existence of the radio window is entirely the accidental consequence of nitrogen and oxygen not strongly absorbing those wavelengths under Earth's current pressure and temperature conditions. Change any variable, pressure, temperature, gas composition, The radio window closes, but somehow it is open. And because of it, humanity can talk to each other across half the planet, observe solar storms from space, talk to Voyager billions of kilometers away, navigate aircraft with radar, search for extraterrestrial life, and transmit billions of gigabytes of data every day. No radio window, no radio, no radar, no Wi-Fi, no GPS, no radio astronomy, no deep space probes, no electronic civilization as we know it. A razor-thin accidental condition, yet it opened the entire scientific and technological era of humanity. When you see the full picture, you understand that Earth is not just where life exists, it is where technology can exist. And right now, we have not found a second planet like it in the entire observable universe. Earth once again proves it is not normal, not random, and not easy to repeat. Because without this radio window, we would not be able to talk to the stars, and we would not be able to talk to each other. Although Earth's radio window has allowed us to look out into the universe with a new sense, what we see out there only makes Earth appear even more extraordinary. Instead of discovering copies of our blue planet, something humanity has hoped for over centuries, data from telescopes and probes reveal a very clear truth. Earth is the exception, not the rule. As of 2024, NASA and other astronomical teams have confirmed more than 5,000 exoplanets. That number is large enough to make you think the odds of finding an Earth-like planet should be high. But the reality is completely the opposite. Less than 1% of exoplanets lie in the zone where liquid water could exist, the habitable zone. But even that tiny fraction promises little, because temperature is only the first of dozens of factors required for life. When we factor in size, the factor that determines gravity, and the ability to retain an atmosphere, we find that fewer than 0.1% are close to Earth's size. That means for every 1,000 planets, only one is small enough to be rocky, yet large enough to hold an atmosphere. But the most troubling part lies elsewhere. Even among planets of the right size and right distance, the vast majority lack a long-lasting atmosphere, or if they have one, its composition is unknown or hostile. And another blow: to maintain an atmosphere for billions of years, a planet must have a protective magnetic field. Yet observations show that most rocky exoplanets either lack a strong magnetic field or show no evidence of one at all. This is the single largest filter among the conditions needed for sustained life. No magnetic field atmosphere, stripped by stellar wind, no liquid water, no biosphere. When you combine the three conditions, right habitable zone, right size, stable atmosphere, and magnetic field, the probability that a planet satisfies all of them becomes so small that some statistical models suggest the chance of a truly Earth-like planet may be lower than 1 in 100 million. That means if you randomly picked 100 million rocky planets in the galaxy, you might, just might, find one with a chance of approaching Earth. And that's without even requiring it to be truly identical. And data from the past 20 years suggests that even the 1 in mice 100 million figure may be optimistic. Among more than 5,000 planets observed, not one has all of the following: a stable, near-circular orbit lasting billions of years, a livable atmosphere, liquid water, active geology, maintaining the carbon cycle, a strong magnetic field, suitable gas ratios, and a host star as stable as the sun. The planets we find are usually too hot, too cold, eccentric orbits, toxic atmospheres, strong radiation variability, or tidally locked, always showing one face to their star. Some may have liquid water beneath ice, but lack sunlight. Some are Earth-sized, but have long since lost their atmospheres. to erosion. Some sit in the habitable zone, but have host stars, too unstable for life to have a chance to form. What astronomers have concluded after decades of searching is this: Earth-like, in the strict scientific sense, is extraordinarily rare. Newspaper headlines often call any planet roughly similar in size or position Earth-like, but to a physicist, Earth-like must mean stable for billions of years, with a magnetic field, a breathable atmosphere, long-lasting liquid water, active geology, and steady energy from its host star, conditions that to date no observed planet fully meets. When you understand that, you begin to grasp a profound truth. In a universe that may contain 100 billion planets, we still have not found anything that truly approaches Earth. Everything out there is either too extreme, too unstable, or too chemically and physically different. Earth, according to all observational data through 2024, is not a typical planet. It is not a copy of any other world. It is a statistical outlier, a phenomenon so rare it is almost unimaginable. And that is why I always say to modern science, Earth-like is not common in the galaxy. Earth-like is something science has been searching for and still has not found. Once we have seen how abnormal Earth is, compared with more than 5,000 observed exoplanets, a natural question arises. Does this abnormality come from Earth's random conditions, or from the very fundamental constants of the universe itself? And when you start touching that question, you encounter an overwhelming truth. Change even one tiny physical constant, and the entire Earth and all life disappears. Physics does not merely produce a special planet. It produces a planet that is special with almost absurd precision. Let's begin with gravity. The constant G cosmologist Martin Rees once pointed out that if G changed by just 1%, stars would become completely unstable. If G were 1% stronger, gravity would compress gas clouds too forcefully, causing stars to form quickly, be small, burn brightly like fireworks, and die in just a few million years. Far too short a time for planets to cool, water to condense, and life to develop. If G were 1% weaker, the opposite would happen. Gas clouds would not collapse enough to form large hot stars. The universe would only have dim red dwarfs, too faint to create the Goldilocks zone. A change so small that humans could not feel it, yet it determines the existence of the sun, the existence of Earth, and your own existence. Gravity is tuned so precisely that this planet can orbit a stable star for 4.6 billion years. But gravity is only the beginning. Consider the electron charge, 1. Coulomb. If that value changed by only 2%, water molecules would become unstable. You do not need to change the world dramatically. Just turn the dial a tiny bit, so small no one would notice, and hydrogen would not bond correctly with oxygen. Result: no liquid water, no oceans, no clouds, no rain, no carbon cycle, no proteins, no DNA, no cells. Earth would become a barren rock, or a Venus-like toxic world, or an ice-covered body like Europa. But absolutely not the blue planet, you know, because chemical bonds, states of matter, molecular stability, all depend on the fragile balance between electromagnetic force and quantum forces. Change the electron charge by a few percent, and the entire biochemistry collapses. But the strangest thing does not stop there. Look at the speed of light. C equals sign. 299,792,458 m per s. This number is not just the speed at which light travels. It appears in every fundamental equation of physics, quantum mechanics, relativity, atomic binding energy, electron structure, molecular stability, stellar density, and even the flow of time itself. If the speed of light changed, even by a tiny fraction, atomic structure would collapse. Electrons would orbit too fast or too slow, unable to maintain stable quantum orbits around nuclei. Atoms such as hydrogen, oxygen, carbon would not exist as we know them. No stable atom, no molecule, no chemistry, no life. As simple as that. A small change, and the universe instantly becomes a shapeless plasma seed. This may sound like metaphysical play, but these are serious scientific calculations. Life exists only when the universe's constants fall within extremely narrow value ranges that are hard to believe. Not wide, not flexible, not random, extremely precise. And when you list a few other constants, proton mass, Planck's constant, fine structure constant, the ratio of electromagnetic to gravitational force, they all share one thing in common. Change them just a little, and the universe will either not form stars, but no planets, form planets, but no stable molecules, or have no carbon, no water, no visible light. A life-permitting universe is incredibly rare. A life-permitting planet is even rarer. And a complex life-permitting planet like Earth, with liquid oceans, stable atmosphere, carbon cycle, magnetic field, circular orbit, suitable sunlight spectrum, and self-regulating biosphere, is so rare, it is almost a cosmic anomaly. All of this is anchored in physics. The universe is tuned with extreme precision to allow structures like Earth to exist. No such fine-tuning, no biology, no intelligence, no one to ask questions about the universe. And that is what makes me smile. Every time I think about physics, the universe does not have to make sense to our intuition, yet somehow it allows us to exist, so we can ask that very question. Earth exists not because it is normal, but because it is the product of a universe tuned in such a strange way that changing even one small constant would prevent this entire story from ever happening. When you realize that changing just one tiny physical constant would make the entire Earth disappear, you begin to understand something profound. The universe is not built according to human intuition. In fact, our intuition is the worst tool for understanding the universe, because the human brain did not evolve to think about things like atoms, nuclei, black holes, or curved space-time. It is optimized for far simpler tasks: finding food, avoiding predators, reading facial expressions, walking on the ground without falling. All those skills take place within the range our ancestors lived in, from 1 meter to about 10 kilometers. The brain is tuned for trees, plains, mountains, streams, objects we can touch, throw, climb, run from. It was not designed to grasp distances of n-half-dm or sizes of 10-half-dm. And that is the problem. Every secret of the universe lies outside the range our brains can intuit. Quantum physics lives at n-1 Nuclear physics lives at 10-1. Interplanetary space lives at 10-1. The Milky Way spans about 10-1. The human brain has no feeling for those numbers. So when I tell you that matter is almost completely empty space, you cannot feel it. You still feel the table is solid. The wall is firm. Your body is dense. But that is only the result of electromagnetic forces pushing you away. When I say an electron is not a little spinning ball, your brain tries to picture it as a ball, because it cannot imagine an object that is neither particle nor wave. When I say time dilates with speed and gravitational fields, you nod because you trust science, but you do not feel time dilation. When I say the universe is expanding, your brain tries to picture it expanding into surrounding nothingness, even though in reality the universe is not expanding into anything. Space itself expands. The brain cannot process such concepts. And this is exactly why humans tend to think Earth is normal. Not because it really is normal, but because it is familiar. We have lived on it since we were born. We see the sky every day. We drink water every day. We see green trees every day. We breathe the atmosphere every day. When you look at something too often, your brain concludes it is the standard. But if you look at Earth with mathematics, with data, with physics, you will see it is a crazy exception whose probability of existing is almost zero. Intuition simply does not feel that. Intuition says Earth is the baseline, and the universe revolves around it, something humanity believed for thousands of years. Intuition says heavier objects fall faster than lighter ones. Wrong. Intuition says moving objects stop by themselves. Wrong. Intuition says time is absolute. Wrong. Intuition says two events simultaneous for me are simultaneous for you. Wrong. Intuition says light is instantaneous. Wrong. Intuition says electrons orbit nuclei like planets. Wrong again. Humans are consistently wrong when looking at the universe through intuition. And because intuition is built from everyday life, from 1 meter to 10 kilometers, it makes us think what surrounds us is normal, when in reality we are living inside one of the greatest abnormalities physics allows. When you read that water expands when it freezes, you think, yeah, sure. But no, that is a rare physical singularity. When you see the blue sky, you think it is natural. But no, it is the result of Rayleigh scattering in an extremely fragile atmosphere. When you see green forests, you do not think about chlorophyll absorbing red and blue light and reflecting green, a coincidence between stellar spectrum and living molecules. When you see a 24-hour day, you think it is obvious. But no, that is the result of the moon slowing the planet's rotation from 6 hours to 24 hours. When you see Earth's orbit is stable, you think that's what planets do. But no, most planets in the universe have eccentric, chaotic orbits or are perturbed by nearby stars. When you see Earth has a strong magnetic field, you think, of course, planets have magnetic fields. But no, most rocky planets lack an active dynamo core like Earth's. When you see radio waves work, you think it is human technology. But no, they only work because the atmosphere happens to be transparent in the 1 mm, 10 m band. Intuition turns extraordinary things into obvious things. But physics does not care about intuition. Physics only cares about numbers, density, energy, constants, structure, orbits, reactions, probabilities. And in the world of those numbers, nothing about Earth is obvious. Your intuition says Earth is normal only because you are used to it. But the data say Earth sits at the fragile intersection of dozens of physical conditions that are almost impossible to coincide. And the universe has no obligation to create such a planet again. Physics does not care about our feelings, but we must learn to overcome intuition if we want to understand what is really happening. When you begin to realize that human intuition never gives you the true picture of Earth, something interesting happens. The deeper you dig into physics, geology, atmospheric science, planetary chemistry, the more you see that Earth is not just not normal. It is almost impossible in a universe governed by the cold rules of nature. Take a simple but decisive example: plate tectonics. We are taught about it in school as though every planet has drifting continents, rising mountains, then eroded, rocks subducting, then rising again. But as of 2024, among thousands of exoplanets confirmed by NASA, there is no direct observational evidence that any rocky planet besides Earth has active plate tectonics. Mars shows signs of ancient tectonics, but died billions of years ago. Venus may have convection, but its crust does not break into plates. Its entire surface resurfaces in massive volcanic cycles without a stable carbon silicate cycle. Mercury has almost no activity. Only Earth, right size, right composition, right core temperature, allows tectonic plates to be pulled, cracked, slid, subducted, uplifted. And it is this very operation that recycles CO creates continents, regulates planetary temperature over hundreds of millions of years. Try to imagine in a 13.8 billion year old universe, hundreds of billions of galaxies, each with hundreds of billions of stars, and only one planet we know truly has plate tectonics. That sounds normal to intuition, but physics says it is a statistical anomaly. Then there is lightning. You may think it is a random weather phenomenon, but every year this planet receives about 1.4 billion lightning strikes, and each strike produces nitrate, a natural fixed nitrogen source that plants and organisms need to build DNA and proteins. Without lightning, the biosphere would starve for nutrients. These electric strikes are fertilizer from the sky, and Earth receives them at exactly the right intensity, frequency, temperature, pressure range for the reaction to occur. Venus has almost no structured lightning. Mars has scattered electrostatic discharges, but pressure too low to produce nitrate efficiently. On thick atmosphere, exoplanets, lightning would be too powerful, destroying the molecular structure of life instead of nourishing it. Once again, Earth operates in a very narrow window that biology can tolerate. And looking up above your head, we have an atmosphere only 100 kilometers thick, yet it functions as a perfect radiation filter. It blocks gamma rays, X-rays, most UVC and UVB, but lets visible light through, precisely the spectrum needed for photosynthesis and vision. If the atmosphere were twice as thick, blue light might be scattered too strongly. If 50% thinner, solar radiation would be sufficient to destroy DNA every time the sun shines. Yet Earth's atmospheric layer has exactly the right nitrogen, oxygen composition, at exactly the right pressure to protect without smothering life. That is not obvious. When we analyze the entire solar system, the abnormality only increases. Jupiter acts as a shield, capturing or deflecting most dangerous asteroids. Without it, Earth would resemble the early Jovian era, constantly bombarded, with no chance to stabilize long enough for life to evolve. Saturn enhances orbital stability of the planets through subtle gravitational influence. Mars is small enough not to become a toxic gas giant, yet large enough to provide clues about water's past and life. A natural laboratory to help us understand Earth better. Venus is a reminder that shifting just 2-3% in orbital position or changing atmospheric composition by 1% can turn a planet into a 460 degrees Celsius hell. Even the 23.5 degrees axial tilt, creating seasons, moderating climate, distributing heat, is unusual. Other planets either have unstable tilts, Mars are tipped over Uranus, or rotate very slowly, Venus. Simulations show that changing axial tilt by just a few degrees can trigger global ice ages or make tropical zones uninhabitable. You start to see the pattern, don't you? One unusual condition, life is sustained. Another unusual condition, ecosystem remains stable. Add another unusual condition, the planet continues creating an environment for biological complexity to develop. Earth is not special at just one point. It is special at the collection of points, each with an extremely narrow value window, where even a slight deviation would turn this planet into a desolate, toxic, or completely frozen place. When you look closely enough, The solar system begins to look like a machine whose parts, Jupiter, the moon, magnetic field, plate tectonics, atmosphere, 1 AU distance, sun's light spectrum, all fit together in a way that seems excessively coincidental. Not in a mystical sense, but in a statistical sense. The probability that all of them align at the right time, right value, right sequence is extremely small. And what makes it more beautiful and stranger is that none of those conditions had to exist. No law of physics requires a planet to have a magnetic field. No law requires it to have liquid water. No law requires it to slow its rotation to create a 24-hour day. No law requires Jupiter to stand there as a giant bodyguard. No law requires the ozone layer to form just in time to protect life when life began accumulating oxygen. And no law requires life to appear at all. Yet it did appear on a planet where a chain of things that look like design emerged from the blind laws of nature. The deeper you understand, the more you realize one truth: the coincidences of Earth are so numerous that you can no longer call it normal. It is a statistical outlier, an anomaly in a universe that is mostly cold, disordered, lifeless. We live inside an abnormality, and most of the time, intuition prevents us from noticing it. And when we have traveled the entire journey, from atoms smaller than intuition can imagine, to water with properties that break every common rule, from oceans moderating climate to the moon, stabilizing axial tilt, from magnetic field shielding radiation to a near perfectly circular orbit, from photosynthesis running on quantum coherence to a biosphere operating like a self-regulating system, then expanding out to the 93 billion light-year wide universe, you begin to see a strange picture. Earth is not just rare, not just special. It is a mathematical improbability, a beautiful accident of physics, where countless conditions that are almost impossible to coincide all happened at once. Look back at each piece. We began at the atomic level, where 99% of matter is empty space, where changing the electron charge by 2% makes water impossible, carbon molecules unstable, and everything familiar to you disappears. Then we move to the molecular level. Water, a substance so anomalous that it expands when freezing, has such high specific heat, it moderates planetary climate, has surface tension enough to form droplets, rivers, clouds. No other substance in the solar system behaves like it. Then to the oceans. 1.3 billion cubic kilometers of water acting as a gigantic thermal stabilizer, transporting energy via thermohaline circulation, keeping the planet habitable even as the sun brightens over hundreds of millions of years. And the moon, an absurdly large satellite, born from the Theia impact, keeping 23.5 degrees tilt stable, creating seasons, creating tides, creating intertidal zones where complex life could evolve early. Then the magnetic field, an invisible armor, preventing the atmosphere from being stripped by solar wind, as happened to Mars, allowing life to persist for billions of years without ionizing radiation, destroying it. Then the 0.0167 near circular orbit, keeping Earth in the Goldilocks zone where water can remain liquid, and Jupiter standing far away like a silent gatekeeper, capturing most of the most dangerous asteroids. The sun shining light at a 500 nanometers peak, exactly the region where human eyes and chlorophyll absorb most efficiently, a coincidence so rare it is hard to believe. And photosynthesis, 99% energy transfer efficiency based on quantum coherence, far surpassing human technology. Then the entire biosphere, marine bacteria producing 50% of global oxygen, forests and oceans participating in the carbon-nitrogen, oxygen cycle that has run stably for 3 billion years, like a dynamic equilibrium system. Each layer you peel back, Earth becomes stranger. Each physical law you check, this planet sits exactly in a narrow value window that is hard to believe. When compared with more than 5,000 exoplanets NASA has found, the absence is striking. No magnetic fields, no liquid water, no stable orbits, no suitable atmospheres, no signs of plate tectonics. Then when we examine fundamental constants, gravitational constant G, electron charge, speed of light c, all must lie exactly in the ranges that allow atoms to exist, molecules to be stable, stars to burn steadily, planets to form. A small change, and the universe as we know it would not exist, let alone Earth. You see, when viewed through intuition, Earth looks very familiar, but when viewed through physics, it becomes a strangeness that does not belong to ordinary probability. If you do not know physics, you think Earth is normal. If you understand physics, you realize Earth is a puzzle. When you know enough deeply, you begin to see it as a miracle, but not a miracle in the mystical sense, but a miracle in the mathematical sense, an extremely unlikely outcome that nevertheless occurred, and precisely because of that, it is beautiful. And if you are the right kind of curious to the point of discomfort when encountering a mystery, then this is the part I like best, ending with a question that has no answer.